So we have here a single shear joint, and what that really means is we have a few rivets or bolts that are experiencing shear stress across one plane or one face of the bolt. And I'm going to zoom in here on this diagram just to show you that. So we have this bolt here, and we have two planes that are connected by the bolt, and across the face right there highlighted in green, we can see that these planes, they're just trying to cut across just one surface area of the bolt, and that's why this is a single shear joint. Now what we are required to do, we need to find out what the safe working load is for this joint. We do know its ultimate shear stress is 50 megapascal. We do know the factor of safety is 2, and we also know the diameter of the rivet. Now to begin with, we're going to use what we have in order to calculate what we want to find. So if we look at this formula for factor of safety, then factor of safety is our, in this case, ultimate shear stress divided by our safe working load that we're trying to find, or safe working stress. Now, if we rearrange this formula for safe working stress, then that's going to give us our ultimate shear stress divided by factor of safety. And we already have the ultimate shear stress, we already have the factor of safety, so we're going to use those values. So 50 times 10 to the 6 for 50 megapascal, and that's divided by 2. So we can see where our safe working stress, not safe working load, the safe working stress is 25 times 10 to the power of 6 pascals. Now, that's what we need in order to find the safe working load, which is what we're going to do now. Now, just before we do that, I am very passionate about growing this channel. Hence, I upload videos 5 times per week, every single day of the week. And if you could subscribe for more content like this and give the video a thumbs up, then that would help out massively. And it only takes a second to do. So back to the calculation. So we're going to find our safe working load now. And if we recall the formula for stress, so if we say stress is equal to our force, or in this case, the force is same as the load divided by area. So all we have to do now is just to rearrange this to find our load, which is the force. So that will be equal to stress multiplied by area. And in this case, we have 3 bolts, so we have to multiply our area by 3. So let's find out what our area is, and then that will lead us to now finding what our safe working load is. So for the area, we're going to say pi multiplied by the diameter squared divided by 4. And we already know what the diameter is, it's 16 mil. But I'm going to convert that into meters. So that will just give us pi multiplied by 0.016 squared and divided by 4. And that will give us an area of 2.01 times 10 to the negative 4 and meters squared. So that's our area. But of course, we're going to have to multiply our area by 3 because why? We have 3 rivets and the shear is going to be across 3 planes. So let's just multiply our area by 3 to get the total for the area. So that's just going to be 3 multiplied by our 2.01 times 10 to the negative 4. So that will then give us 6.03 times 10 to the negative 4, and that's meters squared. So finally now we can find our safe working load by just multiplying what we got previously for the safe working stress and that which we got for the area right there. So what that looks like, so it's 25 times 10 to the power of 6 multiplied by 6.03 times 10 to the negative 4. And that will give us a grand total of 15.08 kilonewtons. And that's our safe working load. So that's a single shear joint. And what we'll do, we'll take this concept to the next level by looking at the double shear joint. So you can check that video out right there where I break down that concept step by step, just like I just did. And I'll see you in the next video.